Standard 6 is about ratios, proportions, and percents. These three ideas are all connected to each other. They have to do with how numbers relate to one another. So let's start off with the most basic idea, which is a ratio, which shows the relative sizes of two or more numbers. So let's start off with a little word problem here and think about how we can use ratios. The state dining room in the White House measures approximately 48 feet long by 36 feet wide. Let's compare the length of the room to the width and express the answer as a ratio. So ratios are often written as fractions. So 48 feet long by 36 feet wide. So to make that make a little bit more sense, I could reduce this fraction. I see 12 goes into both of those numbers. 12 times 4 is 48, and 12 times 3 is 36. So the length of the room compared to the width of the room is a ratio of 4 to 3. I could write a ratio in several different ways. I could also write 4 to 3 as 4 to 3 with the two dots there. Or I could also just write out the words 4 to 3. A proportion is a statement that two or more ratios are equal to each other. For instance, here's a ratio 1 to 2, and I could say that was equal to, for example, 5 to 10. Proportions are often used if you want to think about the scale between things, like for instance a map, or if you were building a scale model. So let's look at an example with the map. The scale on a map is 1 inch is the same as 10 miles. What would the actual distance between the two places be if they were 3.5 inches apart on the map? So this is one you could probably figure out in your head. If 1 inch is 10 miles, you would probably do in your head 3.5 times 10 and get that the answer was 35 miles, and that would be correct. You could also set this up with proportions. So you could write a proportion 1 to 10, and that would equal, so inches goes on the top, the map scale, so I'm going to put 3.5 on the top over here, and on the bottom is the distance in reality, which I don't know. The way you can solve a proportion with an unknown in it is by cross-multiplying. So I can multiply the x and the 1 like that, and the 10 and the 3.5 like that. So 1 times x is just x, and 10 times 3.5 is 35. So if you do out the cross-multiplying in the proportion, you get the same answer you would get if you did it in your head. Now let's try one with the scale model of a car. So a model of a car is 1/25th life size. That means if you had a part on the model that was 1 inch long, it would correspond to a part that was 25 inches long on the actual car. So if a part on the car was 4 feet long, how long would it be on the model? So I'll set up a proportion here. 1 on the model is 25 in reality. And this time I have a part on the actual car, so this time I know about the reality. So I'm going to put 4 down here on the bottom, and I'm wondering about x, the size on the model. So I'm going to cross multiply again. I'll multiply those guys, and I'll multiply those guys. So 25x equals 4. To solve that, I'll divide each side by 25. And I get x equals 4/25 feet. 4/25 feet, that's kind of a funny number. So I'm just going to do some playing around with numbers and see if I can turn that into something that makes a little bit more sense to me. 4/25, that's about the same as 4/24. And 4/24 reduces to 1/6. So that's about 1/6 of a foot. A foot is 12 inches. So that number there is about 2 inches. That little squiggly thing there is math for about. It's pretty common to see a proportion that has a whole bunch of variables in it. If you see one like that, just go ahead and cross multiply again, and you'll get an equation that you can solve for x. So I'm going to multiply 7 times x to give me 7x. And then I need to cross multiply 5 times x plus 3. You need to remember to multiply the 5 by everything. To make that really obvious, I'm going to write it out with the distributive property right here. So I'm doing 5 times x plus 3. And then I'll distribute that out. 7x equals 5x plus 15. So subtract 5x from each side to get all the variables on one side. So 2x equals 15. Divide by 2, divide by 2. That gives you x equals 15 halves. A percent is a special kind of ratio where the denominator is always 100. You're comparing parts per 100. So for instance, 15%, if I wanted to write that as a fraction or a ratio, that would be 15 over 100. So whenever you see a percent, to write it as a fraction or a ratio, you just put 100 in the bottom and whatever the percent is on the top. I can also reduce this fraction. I see that 5 goes into both of those things. So 5 times 3 is 15, and 5 times 20 is 100. So 15% as a fraction is 3 over 20. To write 15% as a decimal, you just move the decimal 2 places to the left. So 15%, the decimal place normally lives right after the ones place, right after the 5 there. So I'm going to move it back 2 to the left. And 15% is 0.15 if you write it as a decimal. We can also start with a fraction and change that into a percent and a decimal. So here's a fraction 1/8. How am I going to write that as a percent? So the question I'm really asking myself is what part out of 100 is that? So I'm going to set up a proportion. 1 over 8 is what over 100? Solve that, I'll cross multiply. 8x equals 100. Then divide each side by 8. So the answer is whatever 100 divided by 8 is. Let's figure that out. I'll write that over here. 100 divided by 8. So how many times does 8 go into 10? Once. So I'll put a 1 up there, 8 there. 10 minus 8 is 2. Bring down the 0. How many times does 8 go into 20? It goes in 2 times, which is 16. That's 4. I'm going to put another 0.0 on the end here. Bring down the 0. How many times does 8 go into 40? I have to put the decimal point up there also. 5. So x equals 12.5. So 1 over 8 is 12.5%. To write that as a decimal, 12.5, move the decimal over 2 to the left, and I get 0.125. So that's the decimal form. That equals 12.5%, which equals 1 over 8. Next, we'll work on some little word problems that involve percent. So what is 5% of 16? What is 5% of 16? So to solve this, we're going to use the percent equation. The percent equation is something that makes it easy to remember how to solve problems like this. Percent over 100 equals is over of. The way these problems are phrased, there's often something that goes with an is and something that goes with an of. When you read this sentence, what is the thing that's connected with the is? Of 16. 16 is the thing that's connected with the of. So you could set up this equation. The percent, that's 5%. So 5 over 100 equals the thing that goes with the is, what, I'm going to call that x. The thing that goes with the of is 16. So now let's cross multiply. 100x equals 5 times 16, so that's 50 plus 30, 80. Divide each side by 100. and x equals 80 over 100. So let's reduce that. There's a 0 at the end of both of those numbers, so I'll just get rid of those right off. 8 over 10, that reduces to 4 over 5. So 4/5 is 5% of 16. Now let's try 7 is what percent of 28? So percent over 100 equals is over of. The percent here, well, that's the thing I don't know. What percent? So in place of percent, I'm going to put x. And is over of. 7 is what goes with the is, and 28 is what goes with the of. So 28x equals 700. That looks like some kind of nasty dividing. Let's see if maybe we can think about doing this an easier way. 7 over 28, that fraction's going to reduce, isn't it? 7 goes into both of those. So I could actually write this x over 100 equals 1 over 4. So let's just think a little bit. 4 times 25 is 100. So 1 times 25 would be what x is. So that means x equals 25%. And maybe you could have figured that out just by looking at the original problem. 7 is what percent of 28? You could kind of think 7 over 28 just reduces to 1 over 4, and 1 over 4 is the same as 25%. There's often more than one way to solve these problems, but the percent over 100 equals is over of equation will always get you an answer.